going to create two functions. I'm going to call one f of x, and it's going to be the square root of x. And I'm going to have g of x, and it's going to be x squared. So that means f of x is the same as x to the 1/2 power, okay? So if I would multiply those two functions, that would mean I'd have x to the 1/2 power times x to the 2nd power. The bases are the same, so I can add those two exponents and get x to the 2.5 power. I'm going to pause there. Is everybody okay with that?
I think I understand that.
Okay? Which I can write as x to the 5/2 power. And I'm going to take the derivative, and I'm going to write it this way. I'm going to take, remember, because this is y, so I replace the y and dy dx with this product. And I can use my power rule, so I'll have 5/2 times 1, which is 5/2, and x, and then I'm going to subtract 1, which is 2/2, and get 3/2. That's my derivative, correct? Okay. So I'm going to now find the derivative of f, and that's going to be 1/2 x to the minus 1/2, or, and I'm going to leave it like this, 2 over x to the 1/2. And I'm going to take the derivative of g, and that's x squared up here. So again, if I apply the power rule, I get 2x. Now, if I multiply by the derivatives, I would have 1 over 2x to the 1/2 times 2x over 1, and I would get, well, I can bring out a red pen, this is kind of exciting. X to the 1st over x to the 1/2. Again, going way, way, way back in time, bases are the same. I'm now dividing, I subtract the exponents, correct? And 1 minus 1/2 is 1/2. And x to the 1/2 does not equal x to the 5/2. They are not the same, are they? So, the derivative of g of x, excuse me, f of x, that's what I mean to say, f of x times g of x is not equal to the derivative of f times the derivative of g. You can't do that. So the question is, what is the derivative of f of x times g of x with respect to x? If it's not the product of the derivatives. Well, it's going to be this. The derivative is something we call the product rule. So I ignore the first, I don't do anything to the first, but I do multiply it by the derivative of the second. And I add to it the derivative of the first times the second function. This is what is known as the product rule. So, if I look up here, f was to the 1/2 power, correct? So under here I can write x to the 1/2 power times the derivative of g was 2 to the x power. So under g prime I can write 2 to the x plus the derivative of f was 1 over 2 to the x 1/2 power. It's right, where did I write? Right here. Times x squared, which is g. So this has an exponent of 1. So I got 2x. Well, what is 1/2 plus 1? That's 1.5. Right? I can add the exponents. Plus, what I have here is x to the second over 2x to the 1/2. Well, now I'm dividing, so I can subtract the exponents. And this is x to the 1/2 power over 2. Well, this is the same as 2x, and I'm going to write 1.5 power is 3/2. I can take this dividing by 2 and make it a coefficient, which is 1/2. Take this exponent, which is 1.5, and make it to 3/2. And now I have 2.5 times x to the 3/2. Well, this is the same as 5/2 x to the 3/2, which was our answer right here.
I'm completely confused because my paper just is now a mess.
Don't worry, we're going to summarize it on the other side.
Yay.
Okay? So this says, and this is the hard part, you have to identify that you have multiplication going on. If you have two functions that you're multiplying, to compute the derivative, you must apply the product rule, which says the derivative of f, excuse me, I want to get rid of that, I didn't want to break that, which says f times the derivative of g plus the derivative of f times g. That's how you have to figure out the derivative of two functions that are multiplying together. Okay? So let me give you an example. So here f is equal to 8x sine x, correct? I could say it this way if I said it out loud. F of x is equal to 8x times sine x, correct? I'll say it again. F of x is equal to the function 8x times the function sine x. So I'm going to say that f of x is equal to two functions being multiplied together, h of x times g of x. And I'm going to say h of x is equal to 8x. Well, then I can say the derivative of h is what, Tyler? If h of x is equal to 8x, its derivative is what? 8. And I can say that the other function, g of x, Ariana, is equal to the sine of x. And the derivative of the sine of x, g prime of x, is equal to what? Cosine of x. Perfect. So the derivative of f of x will be f, which is 8x, or will be h, excuse me, I'm sorry, which is 8x, times the derivative of g, which is the cosine of x, plus the derivative of h, which is 8, times g, which is the sine of x. I am done. So when you use the product rule, you'll get a sum of two products. When you use the product rule, you'll get the sum of two products. So let's just say Owen says that I see it differently. I would write this as f prime of x times g of x plus f times g prime of x. Would he be wrong?
Yes.
Why?
Order of operations. You have to multiply the stuff together first.
Okay, but all he's doing is multiplying this stuff first, then multiplying this stuff. I think multiplication and addition have something called commutativity, which means order does not matter. Okay? Though I do agree with you, you got to do the multiplication of both of these ends first, and then add. Okay? But I just realize that I take the derivative of one times the non-derivative of the other, and then flip them, then add them together. Does that kind of make sense when I say that? But people forget, Callan, say, hey, I'm multiplying. So what I do is on my mind, I look at the function and I say, what am I doing? Am I timesing? So let's look at this. G of x. Am I timesing? Okay, so I could say that G is equal to F times H. Rhea, what would I say F is? Okay, now, in my heart, Rhea, I'm smiling. Are you smiling in your heart? Why? Well, because you know its derivative? Yeah, that's exactly correct. Okay, Jonah, what's H then?
Square root of x.
Square root of x. We've done this one a lot. This is a very popular function, square root of x, okay? Now, are you able to automatically know what it is?
1 over 2 square root of x.
Okay, let me just recap. The 1/2 comes from that the power is a half. And it's in the denominator because when you take a half minus 1, it becomes a negative a half, correct?
Yep.
But it's still the square root of x. Okay, is everybody okay with that? Okay. So, Cal, the derivative of g, what are you going to choose first?
I'll go with the derivative f of x times h of x.
Okay, so what is the derivative? You said the derivative of f?
Yeah.
What is the derivative of f?
2e to the x power
Okay, and what's h?
times the square root of x.
Perfect. Okay, you got half of it correct. Now there's a plus sign, correct? Is there always a plus sign? Yep, unless you get like a negative cosine, then you gotta change it, right? Okay, so now you gotta pick these two, so you went this way, correct?
Yep.
So now you gotta go this way, would you agree?
Mhm.
So, what are you gonna write?
2e to the x times,
Can I write it over?
oh yeah.
Cause this will be in the denominator, right? This is like over, 1, right?
Mhm.
And you'll have
2 to the x
2 square root of x,
over x, yeah.
right? Okay, and then if I wanted to, which I always want to, because there's extremely great lot of gratification when I get to do this. Okay. So my derivative is equal to 2e the x square root of x plus e the x over the square root of x. Ellie, am I multiplying?
Yeah.
Okay. So H equals F times G, correct? Are you okay that I write F this way? X to the -1 plus 1. Are you okay with that?
Yeah.
What is its derivative?
Negative x to the -2.
Perfect. That's absolutely correct, isn't it? Are you okay if I write it like this?
Yeah.
Okay, you sure? That doesn't make you feel uncomfortable? Okay. So then G is equal to 2x squared minus 5. Would you agree?
Yeah.
And its derivative is equal to what?
4x.
4x. Nothing more complicated than that. I'll let you get caught up because you were answering questions. Okay. So the derivative. What are you gonna write first?
-1 over x squared times 2x squared minus 5.
Okay, will you say it again? Oh, you're, this one right here?
Yeah.
Okay, I wasn't paying. You said it right, and there's nothing wrong. It's your teacher's issue, okay? And you'll figure it out someday, all right? So you said -1 over x squared times 2x squared minus 5, okay? There's a plus sign that goes here. So what are you gonna have here?
4x times x to the -1 plus 1.
Okay, I'm gonna do this because I know I'm going to distribute. Does that bother you?
No.
I like saving lines because I don't do very well with space. Okay. So the derivative, when I distribute, what am I gonna get here? These two terms.
2x.
I get a -2x squared over x squared. Right, because that's an x squared right here. That's kind of a poorly written one.
Yeah, -2.
-2, perfect. And then I got negative here and negative here. Are you okay that's positive?
Yeah.
What's on top? Remember it's over 1, right? 5, and on the bottom is,
X squared.
okay. Plus, what here?
4
4, perfect.
plus 4x.
Plus 4x. So now I could write this as 4x plus 5 over x squared plus 2. Would you agree?
Yeah.
Everybody okay with that?
I think so.
All right, Audrey? Now, Audrey, do you see the amount of hair I have on my head? It's not that much, okay? Tables cause me, I'm just saying a warning. You know, you get a lot of warnings now. If you buy something on Amazon and you live in California, there's 15 warnings on it. And all you're trying to do is buy,
And a table from IKEA.
okay, a table from IKEA, all
And,
right?
and somehow it's even worse quality.
Okay.
I didn't even think that was possible.
All right, so the product rule is what caused me to lose my hair, okay? Now, am I multiplying here? Yes. Now, I'm going to apply the product rule. This is a coefficient of f, okay? So I'm going to write this as 3f of x times g prime of x plus 3f prime of x g of x. If Callan or Ella were to do this, they'd have the 3 here, but they'd have g prime of x first, followed by 3f of x, and then 3 plus 3. No, they'd have this over on this side and this over on that side. They'd have them switched somehow, okay? Which is okay. Okay? The 3 just stays there because it's a coefficient. It's there tagging along. Okay, so now I'm going to plug 2 into here, Audrey. Because it wants to know the slope of the tangent line when x is equal to 2. Of this crazy function that you have no idea what it looks like, but you have numbers associated with it, okay? So this would be 3 times f of 2 times g prime of 2 plus 3 times f prime of 2 times g prime of 2. They love, the AP people love this problem, Audrey. Now, Audrey, I also want to point out the number 3 here. Should give you some comfort, gives me comfort, because 3 can only be 3. It's already perfect. 3. Do you know f of 2?
Yes.
Well, here's 2. What is f of 2? 4. Perfect. Times. Do you know g prime of 2?
Yes. 2.
What is it?
2.
Here's x of 2. G prime of 2 is 2. Yes, you're correct. Plus 3. Do you know f prime of 2?
-2.
You're finding these in the table, aren't you? Okay. Times, what's g prime of 2? You probably said it and I didn't hear it. Here's 2. It's got to go into g. Well, here's f. Here's f prime. Here's g. Here's g prime. -1. Now, we take something that looked really, really, really frightening, and it's arithmetic time. I hate to tell you this, Audrey, this would probably be a calculator-free question on the multiple choice. Okay? H prime of 2. What's 3 times 4 times 2, Audrey?
24.
I think you said 24.
Yeah.
What is 3 times a -2 times a -1?
6.
And we get 30 as our answer. Would you agree? All right, excellent. Oh, Colin, you got the worst one. It was either going to be you or Ben.
Not me.
So, I'm going to rewrite it for you a little bit. Are you okay with that? Like, give you a hint? All right.
Yeah.
R of x, parentheses, 1/2 f of x, plus 2. I don't like dividing, I like looking at it as a coefficient, because now I'm going to treat it as like I did with the 3. You got that on here? Okay. Times 3 minus g of x. Alright. So we're multiplying, right?
Yes.
Okay, here's one of our functions. Here's f. Here's our other function. It's h, because I can't call it g, because I can't call this f either. I gotta come up with a different letter. Oh, what would be a cool letter? K would be cool. You notice K has 3 segments in Owen? Exactly 3. And there's a V on the side. Alright, so, which of these you're going to take the derivative of first? K or H?
K.
K. What's the derivative of K? 1/2 times what? Well, how do I write the derivative of f?
I'm just confused why it's like.
Well, I'm taking the derivative of this thing right here, right?
Yeah.
Okay? The 1/2 just tags along. The derivative of f I write as what? It's up in here in the table.
Oh, yeah, that's right. Yeah, just 4.
You're going to say f prime, correct? Right? The derivative of f is f prime. This is f, its derivative is f prime.
Yeah.
Okay. I'm not putting any numbers in yet. What's the derivative of 2?
Nothing.
Nothing. So I got this times 3 minus g of x. So here's the derivative of this first one. I temporarily called it k, so this would be k prime, 1/2 f prime of x, times h, which is 3 minus g of x, plus, now I'm going to have in parentheses 1/2 f of x plus 2 times the derivative of this. Well, what's the derivative of 3? 0, correct? So it's gone. This is like a -1, right? So that sticks around. Minus, what's the derivative of g? What do we call it? G prime. So now I'm going to plug in -5. I'm going to have 1/2 times the derivative of f with -5 in it. Parentheses, 3 minus g of a -5. Plus, parentheses, 1/2 f of a -5 plus 2 times -g prime of a -5. Times, what's the derivative of f when x is a -5? What is g of -5? Plus, parentheses, 1/2. What's f of a -5? Plus 2 times a negative. What's g prime of -5? And I gotta make it negative because of the negative sign, correct?
Yes.
Alrighty. What is 3 minus a -2? I think you said 5.
Yeah.
So I got 1/2 times 4, which is times 5.
Which is 10.
2 times 5.
Yeah, which is 10.
Did he say 10?
Yeah.
Okay. I couldn't hear. Sorry. So what's 1/2 times 3 plus 2?
7.
7/2. Times a -5. What's 7/2 times a -5? I didn't hear you. Okay. So 10 is 20/2, would you agree?
Yeah.
Plus a -35/2, would you agree?
Yes.
And I'm gonna get something over 2, would you agree?
Yes.
And it's negative, would you agree with that?
Yes.
Would you say it's a -97/2? No, that's wrong. Okay. Just seeing if you're following me.
Okay.
What is it?
-15/2.
You know what? Ben is really happy I picked on you right now. Okay? So those are 2 examples of stuff you're gonna get on the AP exam. Okay? The biggest thing, identify that you have multiplication, identify what 2 functions you're multiplying, take the derivative of each of those individually, and then go up here and apply